We're on the second page of the probability notes. So now we're going to look at some more complicated examples. Let's say a professor randomly assigns true-false answers to 3 questions on an exam. What is the probability that the test has 2 true and 1 false answer? So what we're going to do first is we're going to build the sample space, which is all the possible outcomes. So sometimes on these, when there's multiple items, it's good to make what's called a tree diagram. So I'm going to kind of build this over to the side. So I'm going to think about the first question. The first question can have 2 possible answers. It can be either true or false. All right, so this is going to be question number 1 right here. All right, so now let's move on to question number 2. Let's just assume question 1 was true. From there, I have 2 choices. Question 2 can be true or false. But if the first question was false, then the second question could still be true or false. So this second branch, this indicates question 2. And some people don't like this because they see the answers twice, but we're looking at combinations where the first question was true and then when the first question was false. So then we move on to the third question. So I have to consider the outcome from each of these. So true, false, true, false, true, false. I'm kind of running out of room, and true, false. All right, so when I'm listing the outcomes, I'm going to start by just tracing one of my branches. All right, so this is my first one. This would be everything being true. All right, so I'm going to go ahead and erase that because I'm going to move it in a minute. All right, so that would be, oops, just kidding. True, true, true. So this is considered to be one outcome right here. So that's one outcome for the 3 questions. So then I move on to the next branch. I still want to go true, true, but now I'm going false. So it may help you to think about which branch you want to end with. So for the first outcome, we ended here. The second outcome, we ended here. All right, so that would be, let me go back to my blue, true, true, false. So now I want to move on to my next branch. So I want to get to this branch right here. So I'm going to switch colors. To get to this one, I would need to go true, false, true. So true, false, true. And then I want to move to this branch. To get to this branch, I would need to go true, false, false. All right, so I've listed all of the ones where the first question was true. All right, so now I'm going to move on to the first question being false. So I'm going to start with this one. So if I want to end with this branch right here, I have to go false, true, true. So false, true, true. If I want to end with this one, I have to go false, true, false. And if I want to end with this one, I need to go false, false, true. And then this last one we can see would be false, false, false. Okay, so if I count the lines, each line is an outcome. So there are 8 possible outcomes. So we were asked, what is the probability of 2 true and 1 false? All right, so I'm going to highlight these and then I'll go back and erase them in a minute. So 2 true and 1 false. There's 1. There's 2. There's 3. All right, so I see 3 that are 2 true and 1 false out of 8 possible outcomes. So I'm going to take that highlight off. So that would be 3 out of 8. All right, now for part B, what's the probability of all true or all false? So here's all true, here's all false. So that would be 2 out of 8. And you can reduce that if you want to, but you don't necessarily have to. That would be a probability of 1 out of 4. All right, so now we're going to move on to tossing 3 coins. And what we're going to see is it's basically identical to what we just did, because with a coin you had 2 outcomes, and with the true false you had 2 outcomes. So we're going to go ahead and build this tree diagram. I'll try to be a little neater this time. So this is going to be my first toss. I can get heads or tails. So that represents toss 1. Then assuming the first toss was heads, I do my second toss. I can get heads or tails. And same thing if I assume the first toss was tails, I can get heads or tails. So this represents toss 2. All right, so then for the third toss, I've got heads or tails. I just do this off of each branch, heads or tails, heads or tails, heads or tails. So it's basically the same tree diagram I did earlier. So as I go to get my outcomes, if I look at this one, I get there by going heads, heads, heads. All right, so that would be my first outcome. And then I look at my second outcome, so I'm trying to figure out how to get there. I would go heads, heads, tails. Okay, moving on to my third outcome right there, I would go heads, tails, heads. And then for my fourth outcome, to get there, I still go heads, and then tails, and then tails. All right, so moving down, so just kind of looking at the end of each branch. So to get here, I go tails, heads, heads. And to get here, I go tails, heads, tails. To get here, I would go tails, tails, heads. And then you can see the last one will be tails, tails, tails. All right, so I've got 8 outcomes. And if I wanted to know something like the probability of, let's say, 2 or more heads. So I would go through, and that one's got 3, so that'd be more than 2. This one has 2, this one has 2, this one has 2. Everything else has 1 or 0 heads. So the probability of 2 or more heads would be 4 out of 8, or 1/2. So we can see it's essentially the same type of problem as the first one. All right, so for our last example on this page, we're going to look at a box of marbles. So we've got different color marbles. We're going to draw one ball at random. So if we think about the total number of marbles, we have 20 red, 30 blue, 40 green, and 10 white. So if we add that up, we do get 100. So the probability of getting white, there's 10 white. So that would be 10 out of 100. It also asks us to write this as a percent. Now this is pretty nice because it's already over 100, so that would be 10%. So you could write it as 10%, you could write it as 10 over 100, you could write it as 1/10, and those are all the same thing. So red would be 20 out of 100, which would be a 20% chance. Blue, there's 30, so I have a 30 out of 100 chance of getting a blue. That'd be 30%. And then green is the most prevalent. There's 40 of those, so that would be a 40 out of 100 chance, which would correspond to 40%.